Now that we've done some work with probability, we're going to look into different types of events happening. Let's start with 10.4, find probabilities of disjoint and overlapping events. Disjoint is the same as mutually exclusive. This happens when two different events have no outcomes in common. If you want the probability of either event happening, this one, or is an indicator that we simply add their individual probabilities together. For example, a card is randomly selected from a standard deck of 52. Find the probability that is an ace or an 8. Well, let's let event A be all the events that we get aces out of our deck of cards. And there are 4 aces in a deck. Event B, kind of the same idea, but these are the 8s. And there are actually 4 8s as well. This would mean the probability of picking one card and have it being either an ace or an 8, I'll do A for ace and I'll do an 8 symbol, would be just by adding their individual probabilities together. The probability of just getting an ace or the probability of just getting an 8. Our sample space would be all 52 cards. That means the probability of getting an ace is 4 out of 52. The probability of getting an 8 is actually the same thing. Therefore, the probability of getting one card or the other, we have a common denominator. We'll add the numerators together. 4 plus 4 is 8 out of 52. I notice that can be simplified. 4 goes into both of those values, so this fraction reduces to 2 fifteenths, not 4 fifteenths. There's a 2/15 chance that would happen. Just for fun, I threw in an and in here just to show you how the and would change things up significantly. Find the probability that the card is an ace and an 8. Can these be true at the same time? No. There are no aces that are also 8s. Since no card is both, the probability is 0. Kind of like a trick question, but not really. We just have to figure out the difference between the words and the words or. There are certain instances, though, when cards can be more of one type. That's called overlapping, when two events have one or more outcomes in common. For example, probability of picking a heart or an ace. There's overlap there. There's a card that's both, and that would be the ace of hearts. When this happens, we have to kind of alter how we determine the probability. Now, if we want one event or the other to happen, but there's an overlap, we start off the same way that we did up above. We'll take their individual probabilities, but then we subtract out whatever the probability is of getting that overlapping card. Here's how it works. Again, we'll start with that same question. What is the probability of getting a heart or an ace? Well, the probability of getting a heart, there are 13 hearts in the deck. So that probability alone is 13 out of 52. I know we can reduce that fraction, but I want to keep the 52 until the very end because we're going to have some common denominators. The probability of getting an ace, there are 4 aces in the deck. That's 4 out of 52. But then here's that overlap again. What they both have in common is the ace of hearts. This is the overlap part. There's one card in the deck that's an ace and a heart at the same time. And I'm writing this out in detail just so that we get an idea of how this formula works. Therefore, the probability of getting a heart or an ace is found by taking the probability of getting a heart by itself when you pick a card, plus the probability of just getting any random ace, minus the cards that overlap. And there's only one that does that. See, we have a common denominator for all of this. 13 plus 4 minus 1 would give us a total of 16 out of 52. And now I'm going to reduce the fraction to 4/13. There's a 4/13 chance that if you randomly pick a card, it's either a heart or an ace. Let's try another one. A card is randomly selected from a standard deck of 52. Find the probability that it is a face card or a spade. If we take a look at those individual probabilities, the probability of selecting a random face card when picking a card from a deck, remember there are 12 face cards. That means it would be 12 out of 52. The probability of picking a card and having it be a spade, there are 13 of those cards out of 52. Now we have to think about what cards overlap. What cards are both face cards and spades at the same time? There's the Jack, the Queen, and the King. So there are 3 cards that overlap this time. That means the probability of getting a face card or a spade is found by taking the individual probabilities and adding them together, and then simply subtracting out that overlap, getting rid of those 3 that are in both of those sets at the same time. 12 plus 13 is 25, and 25 minus 3 is 22. It'd be 22 out of 52. Divide both by 2, and we have 11 out of 26. That's the probability in fraction form that that event would happen. Last but not least, a card is randomly selected from a standard deck. Find the probability that is a black card or a 7. I'd like you to press pause and see if you can walk through the steps of finding the individual probabilities, what overlaps, if any, and how can we determine the probability of this event happening. Once you feel you've calculated it, press play and we'll see how you did. Did you come up with 7/13ths? There are 26 black cards and 4 7s. Therefore, the probability would be 26 over 52 and 4 out of 52. But there are those 2 cards in the deck that are true in both scenarios. That would be the overlap. The probability of getting that is simply 2 out of 52. So we add the individual probabilities, subtract the overlap, and that gave me 28 out of 52, simplifying that fraction down to 7 over 13. Sometimes we might be asked to work backwards, and this is where knowing the definition is really going to be important. Out of 200 students in the senior class, 113 are either on the honor roll or they're a varsity athlete. There are 74 students who are varsity athletes and 51 who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So ultimately, this is the overlap part. We want to know how many students would be there and what's the probability of that happening. Well, we have 2 scenarios here. We have honor roll students and varsity athletes. If we follow our definition for overlapping events, we would take the probability of selecting a student on the honor roll plus the probability of selecting a student who's a varsity athlete, and then we subtract out the probability of both happening. And this is what we're actually solving for. This is why we're working backwards here. This is what we want to find. And that should equal the probability of having one or the other. So HR is honor roll, VA is varsity athlete. Well, the number of students on the honor roll is 51. There are 51 students on the honor roll. Therefore, the probability of being on the honor roll is 51 out of 200. Just kidding. 51 out of 200. The probability of finding a student who's a varsity athlete, 74. So 74 out of 200. Wow, 74. I've got this. There we go. All right, we're back. Minus what we don't know. We don't know the students who are in both, so we're just going to give that a variable. Call that X. Equals the probability of selecting a student that's either on the honor roll or a varsity athlete. And if you see up above, there's 113 students where that's true. So the probability of selecting one of those students would be 113 out of our sample space of 200. From here, this is just algebra. We're going to work backwards to figure out the probability that a student's on both of those. On that left-hand side, we can actually take the 51 and the 74, and we'll just add them together. That's 125 over 200 minus X equals 113 over 200. We can go ahead and move the 125 to the other side. So I'm going to move that whole fraction, actually. Minus 125 over 200. We have negative X. But on the right-hand side, we're going to get a negative answer as well. 113 minus 125 is negative 12. So if I just divide both sides by negative 1, it just crosses off the negatives. This means the probability that we would select a student who is both an honor roll student and a varsity athlete would be 12 out of 200. Recognize that that can simplify down to 3 out of 50. And there's your probability working backwards. Another way that we can kind of work with probability is finding the complement of an event happening. Now, the way that's spelled, it's not like that event looks really nice today kind of complement. It's just kind of actually going to mean the opposite, which I know sounds so strange. The probability of an event happening is the same as 1 minus the probability that it won't happen. Okay, so here's what I mean. If the chance of rain today is 84%, what is the percent chance it won't rain today? So the probability that it won't rain is the same as 1 minus the probability that it will rain. So if we have 84%, we have to be careful with that. We're not going to plug in 84% into this formula because then we'd get a negative percent answer, and that doesn't seem reasonable. So what we need to do is just think about converting to decimal form, kind of like what we did in Chapter 7. Chapter 7. So if we do 1 minus, instead of 84%, if we do 0.84, the probability would be 0.16 or 16%. So there's a 16% chance that it won't rain. And that's all you do to find the complement of an event. If there are 25 raffle tickets and 7 of them are winners, what is the probability that Mrs. Fry's raffle ticket is not a winner? Aw, what a bummer. So if there are 7 tickets that are winners, there are 18 that are not winners. So therefore, the probability of my ticket not being a winner is just 18 out of 25. That's truly all you have to do. So finding the complement would just be 1 minus the probability that it would happen, meaning that it won't happen, or vice versa. Last but not least, roll 2 dice. How many outcomes are possible? Now, the unfortunate thing for this is one of these dice is supposed to be red, and for some reason it didn't, I don't know why it didn't save, but let's pretend that this is the red die. Sorry about that. We'll just make sure that's red right there. That means if we roll this die, all of our possible outcomes would be in this row. If we roll the blue die right here, all of our outcomes are in this column. So if we roll 2 of them at the same time, how many different ways could the 2 dice land? How many outcomes are possible? If you look at the diagram over at the right, there are 36 different ways those 2 dice could land. It says, what is the probability that the sum is not 6? So if there are 36 total, the probability that the sum is not 6, there's lots of different sums on here. For example, if each of the die lands on a 1, the sum would be 1 plus 1, which is 2. If each of the dice land on 4 and 6, the sum would be 10. So I want to know what's the probability that the sum is not 6. So this is one of those kind of complement possible answers where instead of counting all the sums that aren't 6, it might be faster to find the sums that are. Do we see any sums of 6 in that first row? I see 1 and 5. They would add to 6 right here. How about the second row? If we go just a little down and to the left, I see 2 and 4. And look at this, it kind of continues a pattern. We got 3 and 3. They could also land on 4 and 2. That would have a sum of 6, and then 5 and 1. So there are 5 pairs that land with a sum of 6. Therefore, out of 36, the probability would be 36 minus 5. So it'd be 31 out of 36. 31 are all the different ways they could land and not have a sum of 6. So using that complement rule kind of to look at that picture, instead of trying to count up all the ways it could not be, we found all the ways that were and then just subtracted. What is the sum that occurs the most? Ooh, this will be interesting. What is the sum that occurs the most? What do you see happening the most amount of times? Well, I notice that the smallest sum is 2. That's that very first one right here. The smallest sum is 2. The biggest sum down on the bottom right is 12. Let's see, what occurs the most? That would be the one where we see the 2 pairs adding up to the same number. I kind of think this diagonal right here, if we go all the way down in this direction, notice the sum every time is 7. So the sum that occurs the most is 7. What would be the probability of getting that sum? Well, there are 6 times where it occurs, so the probability of getting a 7 would be 6 out of 36, and that reduces to 1/6. What is the probability of not getting that sum? So if we do probability of not getting that sum, we could apply the complement rule. We could do 1 minus 1/6, and that would just be 5/6. So is it more likely to not get a sum of 7? Yeah, 5/6 is much greater than 1/6. And there's lesson 10.4.